Hi everyone, welcome back to ANR Academy. This is Nepaledi sir. Today we are going to discuss how to draw the graph of y equal to x power x. We know that the graph of y equal to x power x, it is defined for all x more than 0. That is, domain of the function must be non-negative real number. Domain is set of all positive real values. That is, x belongs to open 0 to infinite. See how to draw the graph. On Cartesian coordinate system, this is x-axis and this is y-axis. We know that the graph is defined only for positive values of x. So that here I am going to mention, here it is 0, somewhere it is 1, 2 and so on up to infinite, and here it is, suppose that 1, 2 and so on infinite. You have the function y equal to x power x. First decide in which interval the function x power x is increasing and in which interval it is decreasing. See here, to get the interval in which the function is increasing, let its derivative f dash of x more than 0, and to decide the interval in which the function decreasing, for which put its derivative less than 0. We know that differentiation of x power x, that is x power x into 1 plus log x more than 0 in the first case. Since here it is defined for all x more than 0, here base more than 0, exponent also more than 0, therefore x power x is positive. Product of x power x and 1 plus log x should be more than 0. Already the first quantity positive implies product of terms should be positive whenever 1 plus log x is also positive. Implies I can write log x greater than minus 1, implies x is more than e power minus 1, implies x is greater than 1 by e. So in which interval it is increasing means for all x belongs to 1 by e to infinite, the graph is increasing, remember. Next, to decide the interval in which the graph decreasing, by selecting f dash of x less than 0, we get its derivative x power x into 1 plus log x, it is less than 0, implies you can write 1 plus log x is less than 0. Why? Because x power x is positive. So the second term must be negative, then only positive into negative gives negative result. Implies I can write log x less than minus 1, implies x is less than e power minus 1, that is x less than 1 by e. X less than 1 by e but more than 0, remember. Therefore I can write x belongs to 0 to 1 by e. In this interval the graph decreases, and particularly at x equal to 1 by e. if you write x value 1 by e, its derivative become 0. Suppose if you write x value here 1 by e, log 1 by e, nothing but minus log e. Minus log e value 1. So 1 minus 1 becomes 0, and hence its derivative 0 at x equal to 1 by e. So here it is decided in the interval 0 to 1 by e the graph decreases, and 1 by e to infinity it increases. So in the graph, suppose that here it is of 1 by e. E value, Euler number, that is approximately 2.718, remember. So 1 by e, that is less than 1. And just now we discussed from 0 to 1 by e the graph decreases, okay. In the interval 0 to 1 by e it decreases. Next, from 1 by e to infinite the graph increases, and from here onwards it increases. And particularly at x equal to 1 by e, its derivative 0, that is slope of the function 0. Yes, here it is of negative slope, slope 0, and then positive slope. Yes, at x equal to 1 by e, f dash x is 0 clearly. And as x tends to 0, what happens? The figure observe. Suppose x tending to 0, then what about x power x approachment? Let us discuss this. That is, you need to calculate limit x tends to 0 x power x value. Suppose that limit value is some L. Directly if you write x value 0, it goes to 0 power 0 form, that is indeterminate form. And the limit value you can easily solve by applying logarithm on both the sides. Log L equal to limit x tends to 0 log x power x. Therefore, log L equal to limit x tending to 0 x into log x it is. Now, log L equal to limit x tending to 0, it can be written as log x divided by 1 by x. As x tends to 0, log x value approaches to minus infinity. It approaches to negative infinity. This is the graph of log x. When the values of x approaching to 0, functional value approaches to negative infinity. Next, 1 by x graph. You know that the graph of 1 by x, as x tending to 0, here x value approaches to 0 plus. From right side it is approaching, right? It is defined only for positive values of x. Here the condition x is more than 0 we have. Domain of the function clearly from 0 to infinite, open interval 0 to infinite, so that only the limit we need here 0 plus. So for 0 plus I am going to calculate the limit. See, when 0 plus, the graph approaching to infinity here, the denominator part approaching to infinity. Infinity by infinity model. Applying L'Hopital rule, log L equal to limit x tending to 0 plus log x derivative 1 by x, 1 by x derivative minus 1 by x square. On simplification it becomes minus x. Applying x tend to 0, it approaches to 0. log L is 0. Since the value of log L 0 implies L equal to e power 0, limit value become 1. So here the graph y equal to x power x that approaches to 1 as x tending to 0 plus. So here just it approaches to 1. That's all. So this is the graph. From 0 to 1 by e it decreases, 1 by e to infinity it increases, as x tends to 0 plus it approaches to 1. So this is about the graph of y equal to x power x. I hope you understand everything. The students, those who are watching my videos, please like, share and subscribe my channel. For more videos, please share my videos. Thank you so much.